Bienvenidos, Ushamdid, and welcome to this HUD 8 Consulting Enterprise Networking Security and Automation, or ENSA, CCNA version 7 techtorial on Packet Tracer Activity 5.4.12, where we're going to be taking a look now at configuring extended IPv4 ACLs. Now, up until this point, we've only been working with the standard ACLs, which we can only use to filter on source-based traffic, right? So traffic from the source is the only way to filter with a standard access control list. And that's true whether it's a named standard ACL or a numbered standard ACL. So now we're going to shift gears here and take a look at how we would handle maybe filtering on the source and the destination, and maybe what if we wanted to filter based on protocol. So let's go ahead and dive in to this introductory activity here on extended ACLs. You can see the topology here on the left, and we have our scenario over here on the right with the addressing table. So the first thing that we're going to do is take a look at the background of the scenario. We have two employees. They need access to services provided by the server right here, 172.22.34.62. Now, PC1 only needs FTP access, while PC2 only needs web access. Both computers need to be able to ping the server, but not each other. And so those are the requirements, and this is a good activity. It's going to walk us through what we need to do. So let's jump on to router 1 here. And actually, before we do that, let's make sure that PC1, and we're going to need these windows up anyway, but let's make sure that PC1 and PC2 actually can ping each other right now. And this is going to allow us to confidently say when we complete the activity that they can no longer ping each other. So let's ping 172.16.22.34.66. In other words, I'm on PC2 and I'm pinging over to PC1. We may have a request timeout, waiting for some ARP activity to take place, and then we've got our successful pings. And let's do the same in reverse here. If we can ping from PC2 to PC1, we should have no problems pinging 172.22.34.98. And as you can see there, we didn't even need to wait for an ARP reply to come back. We have full connectivity between PC1 and PC2. Now, we're going to be configuring an ACL here. So remember back to the activity that we did previously, or the activities that we did previously, where we saw that if I go from user exec to privilege exec into global config, if I say access list and do a question mark, this is where we see the numbered ACLs, right? And 1 to 99 is going to be a standard ACL by definition of the number. That is what is dictating whether it's standard or extended. Remember, when we do a named ACL, that's where we have to indicate, is it going to be a standard ACL or a named ACL? But here, with a numbered ACL, the number is dictating whether it's a standard access list or an extended access list. So the standard numbers are 1 to 99, and this is in the sort of regular range, and then there is an expanded range, and we'll talk about that a little later on. But we can see 1 to 99 for standard numbered ACLs, and then 100 to 199 for the extended access control lists. So we're going to say access list 100. If I do a question mark, you can see it's going to ask me, what do I want to do? Do I want to put a remark in here? Always a good practice. Do I want to permit or deny traffic from the host that I'm getting ready to identify? So we're going to go ahead and say permit. Let's do a question mark. When you take a look at the options that we have here, right, you can see that we've got all kinds of different protocols. Now, very important is that IP is basically saying, remember how at the end of the ACL we would say deny any, and that would get all traffic. Well, if you were to say access list 100 permit IP, you are saying permit all protocols, right? So in other words, if I said IP like this, that means GRE, ESP, ICMP, TCP, OSPF. It means all of the protocols that I could possibly match on. So think of that as like any in terms of the protocols, right? In terms of the protocols, when you say IP, that pretty much means anything. But you can see here, we want to say TCP. And so this is another significant difference between the standard and the extended ACLs. Right out of the gate, you can see that I can pick the protocol that I'm working with here to be very granular. Now, a question mark here is going to ask me for the source address, right? Or any, meaning any source address, or I can specify a single host by using that host keyword. Now, the source address, we're really talking about the subnet that we would be looking at. And I'm making the assumption that if it's a single host, we're going to type in host and then the individual IP. When we're using source address, the assumption is we're talking about a network that we would be using. And you can see over here, this is always from. And the way that I like to think of it, and once we get the entire ACL in here, I'll go ahead and expand on that in terms of how you can sort of come up with a mnemonic to remember, because this challenges a lot of learners when they see this IP. And then if I was to scroll down just a little bit further here, when they start to see multiple IPs, they start to question, well, is it from that IP or is it to this IP? How does that work? Or this, I'm sorry, I should say from this subnet to this IP. And so the mnemonic to remember is, think of it alphabetically, right? Permit TCP from either this host or subnet to either that host or subnet. So F and T. F comes before T in the alphabet. So just remember it's alphabetical, from and to, right? Or you can even think source and to, right? S and T. But I like from and to. It kind of helps, an easy way for me to remember which IP or subnet shows up first and which shows up second, which one is the from, the source, and which one is the to, the destination. So hopefully that'll help you out and help you remember that from to, alphabetical. So we're going to permit the TCP protocol from the following network, 172.20, sorry, I'm going to do 16 all the time, .34.64. Now, if we look at that, right, you can see over here that we know that this IP is going to fall within that subnet range. So to scroll back up a little bit, one of the challenging things is with the subnetting, and you can see here 172.22.34.66 has a /27 subnet mask length, right? So if it was a /25, it would be .128. If it was a /26, it would be a 192. If it's a 27, it's going to be a 224. So now the question is, okay, great. We know the IP and the subnet mask. How are you figuring out the network? Sorry, I think I went right by it there. How are you figuring out the network, right? Well, here's the wildcard mask. And if you think of it like this, if you know that you've got a /27, you know the block size, right, that you're going to be dealing with. And here's what I mean by block size. So if it's a /27, and they actually tell us that right here in the text, you can see that we've got this /27. How would I know what the block size is going to be for that? Well, remember, when we talk about subnetting, we've got these, and I'll leave them as all zeros. We have these 8 bits, and we're dealing with the last octet. So 1, 2, 3, 4, 5, 6, 7, 8. And these all have values, right? 128, 64. And I should probably stagger these: 32, 16, 8, 4, 2, and 1. So these all have values. Now, when I say I'm using a /27, I mean I'm borrowing from the host bits to make network bits. And so what it means is That's going to be a 1. That's going to be a 1. And this is going to be a 1, right? So up to that point, it would be a 24. This would be a /25, /26, and /27, right? So we're right here with that value of 32. And so with that value of 32, the block size, I can tell you every subnet that will be a member of, or that would be possible to be used with a /27 and the 172.22.34, and we're saying it's a dot 0 to begin with, right? So you always start with 0, and then you just increment by the block size, which is the value here of the last bit being borrowed for the network address. So it would be 0 and then 32, and then 64, and then 96. And you see this 96 is probably going to come up again because this IP here is definitely not in the same subnet because 64 goes all the way to the broadcast. So that's the network ID is 64. I'll put a little line between these guys. The network ID is the top number, and the bottom number is going to be our broadcast address. And so 32 would go to 63. It'd be .63. And so my usables would be 33 up to 62 for this subnet right here, the second subnet that would be available. Broadcast here would be 31. My usables would be .1 to .30. And then for the 64 network, it would be .65. Whoops, sorry, .65 to .94. And you'll notice a few things, right? The network ID is always going to be even, and the subnet, the broadcast address is always going to be odd. And then you would just continue to increment to get a list of all of the different subnets that could be used as we subnet out that 172.22.34. And again, starting at .0 is what we're doing here. And that IP address falls within this subnet right here. All right, so let's clear that screen, and that's how you can figure out what IPs are actually usable. Now, they show you the binary method of working out how to figure out the wildcard mask. Again, my preference is to simply do all 255s, in other words, 255.255.255.255, and then subtract the subnet mask from that. And that's going to give us the same result. And I think you would agree that it's a little quicker than breaking it out into binary. All right, so we've got this access list here. And right now we're all the way out to the from IP. Now we have our subnet mask, right? Because it's any IP address in that, wildcard mask. I keep saying subnet mask. Wildcard mask is 0.0.0.31. And any IP in that subnet, which is what I was thinking about when I said subnet mask, any IP that falls within this 64 subnet, which is going to be from .65 to and I erased it already, 94, I believe, because 95 would be the broadcast address. So any IP in there is going to be, it's TCP from any IP address in that range. PC1 is in that range. And so now, excuse me, what are we trying to do here? So that's our from. Where are we going? Well, we're going to the host. And we know the host sits right up here. We don't need to worry about subnet masking up here because we're putting down the actual individual exact /32 IP address, 34.62 of the server. And so what this says is permit any protocol that's using TCP, any TCP protocol from any host on this subnet here, and that's PC1 is who we're worried about, going to this host. And if I do a question mark here at the end, and let's keep up here, let's continue to scroll, you can see that we can actually indicate the protocol that would be allowed by this host. So I'm saying any TCP protocol, any protocol that, any application that's using TCP as a protocol, going to this host requesting equal to FTP services. Let's bring that down a little bit. Excuse me. And you can see that right there is the complete command, right? That's what we're looking for. Access list 100, permit TCP from any host on that subnet 172.22.34.64 to the individual host, the server 172.22.34.62, if it's FTP coming to the server, right? And so I'll hit enter. And there's our first entry. It says create a second ACL statement, an access control entry, an ACE, that's going to permit ping traffic from PC1 to the server. So let's go ahead and say access list 100, permit. Now remember, ping is using ICMP, right? So I'm allowing ICMP packets from the 172, I keep wanting to do 16, 22.34.64, right? So any host on this subnet going to host 172.22.34.62 using ICMP. Let's say do show access list. Whoops, sorry. Do show access list. And here you can see that we've got our two access control entries, or our two ACEs. Now, we're going to apply the ACL on the correct interface. And so here is where the discussion starts as to where would we put this ACL. Because with standard ACLs, the ACL needed to be placed as close to the source as, close to the destination with the standard ACL, as close to the destination as possible. With an extended ACL, it's just the opposite. We want to get it as close to the source as possible. And so they're saying on an actual operational network, it's not a good practice to apply an untested access list to an active interface. And that is 100% true. Now they're asking us to place this on gig 00 in the inbound direction. And so in other words, we're going to place the ACL here, and it's being placed in the inbound direction. In other words, traffic coming into this interface, and that traffic would be this 172.22.34.66 host, because that's the only host we have on this subnet right now. And so our ACL is allowing traffic to go to the server if it's FTP traffic, and excuse me, and also ICMP traffic. So let's go ahead, clear the screen here. And we're going to make the application of the ACL here. So let's get into interface gigabit 00. And we're going to say IP access group 100 in the inbound direction. So we've placed it here on that interface right there, gig 00. So now it says verify the ACL implementation. So I'm going to come down here, and we're actually going to FTP. I was going to try a ping off of that, but let's go back to the desktop, get the command prompt up, and let's say FTP to 172.22.34.62. And you can see we get a FTP prompt. No worries at all there. Now let's ping from PC1 to PC2. The destination host should be unreachable. Remember, PC1, we did the ACL. However, if I was to ping 172.22.34.98, in that ACL, we allowed ping, but we allowed it to go where? To the server address, to that specific individual address. And so what do we have at the end of this ACL? Again, if I were to say do show access list, do we see, show access list, do we see the denies? And the answer is we don't see the denies because we don't have an explicit deny any down here at the bottom, right? Or deny IP any. So we don't have that laid out down here. So you can see that we don't even see a match here because, again, we haven't pinged. And let's go ahead and we can ping the server. We'll say ping 172.22.34.62. And now we've got some ping traffic we've generated. And so we've got some matches that we can see there. So again, everything looks good so far via FTP as well as ping. Now we're going to configure and apply and verify an extended named ACL. And so this is what's going to allow HTTP access and ICMP from the PC2 LAN over here, which is this 172.22.34.96 subnet, and it's a /28. So the block sizes are going to be in increments of 16 if you wanted to see the usable IPs in that range. Right now we've got different subnet mask lengths here. And so what I can do, I'll start, and again, the example I gave, I was saying I was starting from 34.0, but we've got some different subnet mask lengths here, and I'm going to actually work that out for you so that you can see what all three of these subnets look like and what their usable IPs would look like. When I was doing the block size earlier, again, stipulated that we were just assuming that we're starting from the 172.22.34.0 and that all of the subnet masks were going to be the same length. That way you would get down how it was I was coming up with the block size and the usable IPs, the subnet ID, and the broadcast address. So we take a look at this here on router 1, and we're going to do a named ACL. So we're going to get into global config. I'm going to say IP access list. Now, remember, I have to explicitly state whether this is going to be extended or standard. So we're using an extended ACL. The name is going to be HTTP_only, right? Now, that's it, because I have to hit enter here. You don't do it all on one line like we did with the numbered ACLs. And so now it's in here that I can put some sequence numbers. I can make adjustments if I needed to, right? By sort of filling some holes in the ACL to add in some additional access control entries, or I could just remove access control entries using the no negate command. So what are we doing? Well, we're permitting TCP because HTTP is a TCP protocol, right? So when the source initiates that TCP connection, or the HTTP connection, it's going to be using the TCP protocol. So permit TCP, and here's where we have a different, and I love how they do this here. They're going to give us the alternate way to do it, and what I clearly believe is the quicker way to determine what the wildcard mask is going to be. So we're going to be coming from the 172.22.34.96 subnet with a wildcard mask of 0.0.0.15, right? So that's from the source, which is the PC2 LAN. Now, we're going to that individual host, the 172.22.34.62. And here's where we need to qualify. Well, in that IP packet that's traveling from PC2 to router 1 and trying to get to the server, right? What protocol, if the source checks out, if it's a TCP request, and the source IP is in this range, for the destination IP, what protocol do I want to sort of be very granular and say we're going to be using here? It's going to be, and I'll do a question mark for you, it's going to be www. Now, there are many more protocols. I could even use the port number, right, 80 for HTTP, but we can also use the keyword www. Right? And so that's the entire rule. So router 1, the ACL that's going to be placed right here, the extended ACL, which is being placed as close to the source of the traffic as possible, is dictating any IP in that range for the source IP field that's using TCP as the protocol, or some application that leverages TCP as the protocol, going to that destination IP value in the IP header using HTTP, right? That's what we're going to allow. And then we're going to say permit ICMP 172.22.34.96, and we're going to do 0.0.0.15, and we're going to say going to host 172.22.34.62, right? And so that is our extended named ACL. And I'm going to pull this back a little bit here because we're going to start to apply things. And actually, I'm sorry, I misspelled permit. Let me pull this back. There we go. All right. So if I say do show access list, You can see we've got two ACLs, but the HTTP only ACL is the one we just configured. And as you can see, we're allowing ICMP, so we're allowing pings, and we're allowing TCP connections from any host on that subnet, any application using TCP. But here, it's going to check to make sure the destination that it's going to, it has to be HTTP, or else it's not going to allow it through, right? So you can see how granular we can be here, okay? All right, so we've already looked at the ACL. Now let's just go ahead and do the application of the ACL. Let's get into int gigabit 01, and we're going to say IP access group HTTP only, and in the inbound direction. So now let's verify from PC2, can we ping the 172.22.34.62? And that should work great. In fact, if I was to quickly go back to router 1 and say do show access list, we should have some hits on the ping rule, right? You can see right there. And the completion percentage is at 100, but hang with me here because I want to talk about it, again, that best practice at the end of these ACLs. And so it says from PC2, open a web browser. So let's go back to our desktop. Let's kick the web browser open, and let's say 172.22.34.62. And there we go. And we've got a small page here. We've got some copyright info, right? So showing us that HTTP is working. Now, if I come over to PC1 and I go back to the desktop and I open a web browser up, is this going to work? 172.22.34.62. What happens? You can see nothing is happening, right? Because we didn't allow, the request timed out because we're not allowing that traffic in the ACL, the numbered ACL that we have for PC1 subnet. We're allowing FTP and we're allowing ping. We're not allowing HTTP, right? So those are our two rules, but let me ask you this. So now your boss comes back to you and says, well, this is great, but we definitely want to know if someone's trying to access the server who's not supposed to be, or if they're trying to access it with a different protocol, maybe they're trying to SSH to it, maybe they're, something like that. So what would we do? Well, we would have to make two quick adjustments here. And how would we do that? Let's exit out and get back to global config. I'd say IP access list, IP access dash list, and we're going to say extended 100. So now I can see everything we have in here. So I'm going to say 900 deny, and again, we've got to pick the protocol here, right? So we're saying deny IP because, as I said before, that's like an any. That's every single protocol that could possibly be used. So deny IP any. And what that means is deny all protocols from any host to, from anywhere to anywhere. So in other words, deny everything, right? And then I would want to do the same thing. I'm going to say IP access list extended HTTP underscore only. And I'm going to say 900 deny IP any. And so now let's save our config here just in case. Now let's go ahead and take a look at our ACLs. And you can see that we've got this explicit deny IP any at the end. So if I pull this back up and say go, and hit go a couple times, right? Trying to make that HTTP, you can see the green lights are flashing as I'm doing that, right? But these green lights here, not so much, because that traffic is being blocked. And so that's just, again, to generate some traffic. And if I come over to PC2, if I pull up the command prompt, what if I say from PC2, FTP to 172.22.34.62, right? Trying to connect. Now let's come back. Let's take a look at these ACLs again. And boy, oh boy, did we go bananas right here with the HTTP. Take a look at that. So we've got, if you see something like this, you may want to start to investigate a little further what might be going on. But most importantly, the takeaway here is with an explicit deny any, right? And it's deny any when we're using the standards. I just say deny any instead of having to say deny IP any. But with a deny any at the end of the ACL, explicitly defined, we can actually see if someone or if traffic is trying to get to the server that maybe isn't supposed to. And then again, this would spur subsequent investigation. All right, well, that is going to do it for this packet tracer activity 5.4.12, where we saw just how easy it is to configure extended IPv4 ACLs, both named and numbered. We saw how we can modify those as well by putting the explicit deny IP any at the end of those ACLs. And we should be clear, right? Remember, first IP or subnet range is going to be from the source. The second IP or subnet range is the to, or the destination. And extended IP ACLs or extended ACLs, Cisco best practice, get those placed as close to the source as possible. All right, thank you so much for watching. Best of luck to you in your studies. Thank you, and I hope to see you in the next video.